As the name suggests, the adaptive DMC engine adds adaptivity to the image sampling process in V-Ray, meaning that based on user input parameters, the engine can and will make some very deliberate decisions regarding where and how it will place and use samples in the scene. Now, given that the engine is the default inside of V-Ray for SketchUp, chances are that each and every time we start a new scene, we're going to be working with the adaptive DMC engine from the get-go. Indeed, if I open up the options editor and jump into the image sampler rollout, you can see that this is indeed the case in our start scene here. Now, whilst we don't have tons of control parameters when using this option, we clearly have more than the fixed rate engine gave us. The main control parameters here are these min and max subdiv values. These give V-Ray the option to make use of as many or as few samples according to the min and max values as it deems are necessary in order to achieve the desired level of noise reduction in an image. On its first pass, V-Ray will always use the minimum number of samples available, and then using either the colour or DMC sampler threshold values as a control mechanism, it can and will add more samples as and when they are needed, working up to either the max subdiv's value itself or to the specified cutoff point as determined again by either of the threshold values mentioned. One note of warning worth sounding here is that we never want to set our min and max values to the same number. If we do that, we effectively kill the engine's ability to be adaptive. Then, the DMC engine will simply function as per the fixed rate option. The renders we get will be identical, the render times we get will be identical. Whilst the default settings here of min1 and max4 are fairly fast, I find, particularly at the start of a project when things are really only getting roughed in, that I can probably get away with settings of something like 1 and 3 or even 1 and 2. Let's take our first test render using the defaults that we have in place though and see what we get. Well, as you can see, we do indeed get a pretty decent result right out of the box. All of our textures are reading pretty well, the noise on the wall and shadow edges are much cleaner than was the case on our first fixed rate pass, and indeed what we are getting here is more than double the image quality for just about double of that original render time. Let's see what happens to our image then as we increase the max subdiv's value. Now, I mention only the max subdiv value here because in these tests we're not going to be touching the min value at all, given that there really are very few scenarios in which we would need to increase this to anything higher than the default of 1, although clearly that is something we can do should we deem it necessary. Let's go to town with our max subdiv value then, setting it to something like 16, save what we have to history, and then take another render. What we get now looks pretty good and is in fact very comparable in terms of quality to our final fixed rate render, although in this instance the render was completed in about 2/3 of the time. We could get even more mileage out of our max subdiv's value here by coming to the DMC sampler rollout and working with the noise threshold value. This essentially works as a control mechanism that determines how many of the max subdiv samples available can actually be used at render time. Higher numbers tell V-Ray to be less vigorous about cleaning up image noise and so will use fewer of the total samples available, whereas lower values do the opposite and tell V-Ray to work much harder at cleaning up the noise and so can ultimately lead to us using more, if not all, of the maximum sample count made available. The strength of this engine then is, of course, its ability to be adaptive. This alone makes it, in my honest opinion, the best choice of sampling engine for most production situations. Adaptivity benefits both the render quality and the render times, as it lets the engine make intelligent use of the samples that we have made available to it. Also, if we are rendering scenes that have significant memory requirements associated with them, the fact that the DMC sampler doesn't need to hold all of its sample info in memory can be a massive aid to us simply being able to get a scene rendered at times. Although, incidentally, this same fact is also true of the fixed rate engine. In terms of weaknesses, there really aren't any as such that I would ascribe to the DMC engine. It is capable of producing the very highest quality, but it can also be configured to any balance of speed versus quality in order to suit the needs of our particular rendering project. The only thing you could perhaps say against it is that, whilst capable of being adaptive in its sampling approach, the engine isn't able to perform any kind of undersampling. Which brings us in our next video to the adaptive subdivision engine, which in fact can.